everyone, in this video, we are going to graph exponential function, and this is the first part. In this part, we are going to look at the equation y is equal to b raised to the power x. So our b here is the base, and then the x is an exponent. So let's take this first example right here. Sketch the graph of the function f of x is equal to 3 to the power x. Now please remember that this function notation that we have here can be written in equation form, which is y is equal to 3 raised to the power x. And this matches up to this form, general form that I wrote on the side over here. So our y and x are our variables, and then the b here, or the base in this example, is 3. There are steps that we need to follow in order that we can graph this exponential function of this form. Now the first step is to set up the table. So I'm just gonna label this as step 1 right here. Okay, so I've set up the table, and our next task is to fill this table in. So the first thing that we're going to do is we will pick numbers on the x that we plug into this equation here in order that we can solve for y. So we can go ahead and pick -2 here. Okay, so I've picked -2, -1, 0, 1, and 2. So what are we going to do is we plug these values into this equation that we have here so that we can solve for y. So if we look at the first one, that would be 3 to the power. The exponent x is -2, so I put in the 3. I wrote that down here. And then I will put in the x, which is -2. So I put a -2 here. In order that we can simplify this exponential form right here, we're going to use this property of exponent. So if we have a over b, this is in fraction that's raised to the power -m. This can, if we want a positive m, we can switch the a and b. That's how we got here, b over a, and now the exponent is a positive m. So we're going to use this property. I'm going to put this property right here, and we're going to use this property in order that we can simplify this. Now, please remember that this 3 raised to the power -2 has an invisible denominator of 1. So there's invisible denominator of 1. I just wrote a broken line right there to denote that it's invisible. So then we can go ahead and rewrite this as, I switch the 3 and the 1, so that becomes 1 over 3. And that is raised to the power 2. So it becomes a positive 2 now because I flipped it. So once we flip the fraction, then the exponent becomes positive. So then property of exponent means that 1 gets a exponent of 2. So 1 raised to the power 2 is just 1. And then 3 gets the, because this is in parentheses, it means that they're together. So the 3 gets an exponent of 2. So 3 squared is 9. So we can go ahead and simplify this as 1 over 9. And if we use calculator to determine the decimal version of this, we can have a 0.11, and then 1 is just a repeat. Now let's do the next problem right here. It's pretty much the same thing. Okay, so what I did with the exponent of -1, I exactly set it up exactly the same thing as that, but this time around the exponent is 1. Again, there is an invisible denominator of 1 under this, so I flipped it using this property right here. So 1 raised to the power 1 is 1, 3 raised to the power 1 is 3. If we want the decimal version of this, that's 0.33. Now let's have the 0. So we go ahead and write 3, and then again the exponent is 0. Anything raised to the power 0 is always 1. So that's 1 right there. And then we have a 1. So we go ahead and write 3 raised to the power. That's a positive 1. And that is equal to 3. Now others are going to ask, like, why is that you're not switching this out? The reason why I didn't switch this, the fraction, it's because it's already positive. So whenever we have a positive exponent, where we can just go ahead and simplify it. But in this case right here, since this the exponents of these two are negative, so I had to flip the fraction. So the same thing that would happen to the exponent of 2. So we already have set up the table. Now we remember that for this kind of problem, for this kind of equation that we have here, y is equal to b raised to the power x, our asymptote is always y is equal to 0. Please remember that an asymptote is either a line or a curve where the graph gets closer and closer to it, but it doesn't touch it. So that's an asymptote. Again, we remember that for this type of equation, y is equal to b raised to the power x, the asymptote would always be y is equal to 0. So going back to the table that we have here, the second step is to sketch the graph, and we're going to use these values that we have here in order that we can sketch the graph here. So first thing that we have to do is to write the asymptote. The asymptote is that this is a horizontal line which is located on y is equals to 0, and I'm going to draw the asymptote right here. Okay, so I've labeled the asymptote. That's y is equals to 0. So the next thing that we're going to do is to use this to use these values that we have here. So we start on -2. So that's -2. It goes with 0.11. So 0, that's 1 right there. So 0.11 should be a little close to 0. So it should be somewhere around here. And then I will have to plot the rest of them. Okay, so I've plotted the points. Now I'm ready to connect these points together. Okay, so once we connect these points, make sure that this other tail of this graph does not touch the asymptote, because again, an asymptote is an imaginary line where the graph gets closer and closer to it, but it's not gonna touch it. So it's gonna go dive into this asymptote, but it's not gonna touch it. So an asymptote is like a wall. Make sure that this graph does not get through the asymptote. On the side, you will see the Desmos version of this graph right here. You can see that the paper version that we just did a while back is pretty much the same as that of the Desmos version on the side. At this time, I would encourage you to pause this video and try this problem out on your own. And when you're done, unpause it and check your answer. Okay, so we go over the problem here. Again, the first step is to set up the table. Again, we can actually rewrite this in equation form. That is y is equal to 1/2. Our base is 1/2 raised to the power x. So for step 1 right here, I'm going to set up the table of values for this graph. Okay, so I've set up the table. Now we are ready to fill this table in. So first we are going to plug the values in. So we're going to start with -2. So I'll put in, that's the x. So I'm going to put that into the x. So this would come out, that's going to be 1/2 raised to the power. The exponent again for x is -2. Again, we use this property right here. So if we get a fraction and it's raised to a negative exponent, to make the exponent positive, we flip the fraction. So in this case right here, I can go ahead and rewrite this as 2/1. So I flipped a fraction, and so the exponent becomes positive. So each of this fraction gets the exponent. So 2 squared would be 4. And then that is 1 squared would be 1. And so this would give us a value of 4. And I will do the rest of them here. Okay, so I've already filled in the table. Now we remember that the asymptote for this type of graph, which is in general form of okay, so the asymptote for this form of equation would always be y equals 0. So we go ahead and move on to step 2, which is to sketch the graph. Okay, so I've drawn the asymptote. Now we're ready to sketch the graph. We start with -2. It's going to be on +4. So -2 is going to go to 4. So it's going to be right here. And then we have -1 and 2. So -1 goes to 2. And I will draw the rest of them. Okay, so we're ready to connect the dots together. So we're gonna connect these dots going up there. And then again, remember that this graph is gonna dive towards the asymptote, but it's not gonna touch it. So I'm just gonna draw the asymptote right here. I'm just gonna draw the other end of the graph. Again, it's gonna get closer and closer to the asymptote, but it's not gonna touch it. So the equation of this graph is y equals 1/2 raised to the power x. On the side, you will see the Desmos version of this graph. As you can see, the paper version that we did just a while back is pretty much the same thing as that of the Desmos version. Did you get the same answer as this? Good. Perfect. If you find this video helpful, hit like and subscribe for more math videos. See ya!